Welcome back. In today's video, we're going to cover a few other topics related to functions. There's a lot to cover, so I'll just get right into it. The first thing we got to cover is static variables. So static variables are variables that persist even after the function ends. So for example, these variables don't persist because they're parameters, they're passed in, and they're copies of what is passed into there. And this is a variable that's created inside the function, and then it stops existing unless we return it. Then that gets returned. So if I want to keep track of a certain value each time we run this function, then I can do that with a static variable. So let's just go for it with static int code number equals 1, let's say. And then we'll do cout to say the code number, and then we will output that number. So we'll say code number, and then we will output a colon so it looks nice. Okay, and then we'll want to increment that number each time the function runs. So essentially, this number is just tracking how many times this function has been executed up here. So it should be about 5 times. So if I run it, we get code number 1, number 2, number 3, number 4, number 5. And so simple as that, we've got a variable that updates every time this function is run, and it stays updated. I don't really use this too much. I use it more in relation to classes, the static keyword. So it's up to you whether or not you really want to use this. So, but it is there if it's an option. That's really what all of these are going to be that I'm going to go over. They're all optional stuff that you can use if you want to. Okay, so I'm going to ignore the secret code stuff for the rest of the video, so let's just comment that out. And you can do a big block comment like that if you do /* and */ like that. So let's push all this stuff down here so we're not distracted by it. And we'll be writing some stuff above main now. Okay, so one thing I need to do is talk to you guys about overloading functions. So overloading is well, let me just get started by presenting a problem to you. Let us say that we want to determine which of two numbers is the bigger one. So this is a simple problem. Usually there's a function called the max function. So we'll just get the max. We'll calculate our own max function here. We'll say int max, int a, and int b. So we'll declare it, and then I'll just define it right down here too. So we have everything on the same screen. So we've declared it, now we'll define it. And by the way, you don't actually, I think you should be able to get away with this if you just define it and declare it at the same time. But so we can just return a is greater than b. That's our question. And if a is greater than b, then we return a. Else, if it's not greater than b, we return b. Okay. And now we're just going to do simple cout down here in main to test our function. So we'll do max of 1 and 2 and an indel. Oh, don't forget those. And we'll do another max of 4 and 3 to get those. And we'll run it, see what we get. Yeah, 2 and 4. Okay. So what happens if I want to compare two decimal numbers? And let's say that they're within the same integer. So we'll say, if I'm going to compare 1.2 and 1.3, what's going to happen? I'm going to get 1. And that is because whenever I pass these parameters into the function, it is implicitly, it doesn't really say it, but it's implicitly converting these 1.2 and 1.3, it's converting them into an int. So it just truncates that decimal point. And so we've got 1 and 1. And so regardless of what happens here, 1 is going to be the same as 1. And so it returns 1. If we wanted to actually get the actual value, we would need to code a new function that deals with float types. So both float and double, I should say, because you'll see in a moment. So we'll deal with this with floats, and we'll deal with this with doubles. So this is what's called function overloading. You can have multiple functions with the same name, but with different parameters and return types. So again, this line right here is the signature of the function, and so that has to be unique. And so the name can be different, but the signature determines whether or not it's a different function, really. So you'll see here, I can do integers, floats, and doubles. So the difference between a float and a double is this f right here. So if this decimal thing has a f on it, then it's a float. If it's just a decimal with no f, then it's a double. So in order to make sure that this works with all three of those, I'm testing them all right there. It should return 2 and 1.3 and 1.3. Yep. Okay. So that's overloading a function. So now what I want to do is show you about a template function. Okay. So we can go one step further, and we can define a template. So in order to do that, I'll need to type template type name t. So that's the first step. Type name, you can either say type name or class, but the idea is that I prefer type name just because it's more direct about what it's doing. But t is basically the type name. So we'll do a simple print function because this is the simplest way to show it. We'll do void print. We'll make it constant t because we're not really changing anything. And we'll do std cout t, and we'll do std and l. Okay. So very simple. It just makes this a little bit easier. Instead of having to do that std and l thing, I'll just wrap it in a print function, just like that. And also, if you ever see the word wrapping, that's what it means, to sort of wrap something around it. So I'm wrapping the print function around my max function, sort of like wrapping a Christmas present or something. Okay, so now I'm printing out the max value between those things, and if I run the program, it should work just fine. Yep. So you'll notice that I only had to define one print function despite all of these different return values up here, whether it's an int or a float or a double. This template function deals with all of them just fine, and it returns their actual value. It doesn't truncate them to an int or anything. That's because we're passing in this type name t right here. And type name t could be type name x. The idea is just this is the placeholder for the type name. It can also go a step further and have like more stuff in here, like int I or something like that. You don't need to think about that too deeply. Like if you wanted to, if you had like a different function that wanted to multiply by that I value, you could do that, like t plus I or whatever, and then you'd have to do something a little more complicated than that. But basically, don't worry about that. There's some flexibility with the template function stuff. You don't really need to get into that unless you're doing some really complicated stuff, but it's there if you want to deal with it. So now, the last thing I want to address, and then we'll combine all this stuff together in one big thing, is inline functions. So let's say I wanted to, have all of these in different files or something. We'll cover that eventually too. But for now, let's say I put this down here. So the first thing I need to do is define this up at the top. And in order to do that, I'll need the template thing on both of these. So we'll do template like that, just like that. Okay, so it's been declared up here, and then now we're defining it down here. So, so now this is going to compile just the same as it did before. Okay. However, there's a special thing that we can do, and this is only recommended for really small functions. Okay, we can inline it, and this is true whether it's a template or not. You can inline any sort of function. You could even inline these. Actually, the thing is though, since we're inlining it, the idea of an inline is that it needs to be all on the same line. So let's remove our definition down there, or our definition down there, and just stick it right here. I don't like the way that's formatted, but okay. All right, yeah. So what's he complaining about here? Okay, there we go. All right, so you can see we just inlined it, and if I run the program, it should run just as it has always been. So these are all different options for you to consider when programming different functions. The significance of this is that essentially the compiler looks at this and it unwraps it unwraps the function name and just copies and pastes the code here. Now the problem with that is that it'll make your program size a lot bigger. And so even though it's a little more optimal maybe to get rid of like all the overhead for like the pointers to the function and all that stuff that would deal with the stack state, pushing and popping. We'll get into that stuff later. But there's a little bit of optimization in that, but you'll lose it pretty quickly if this function gets to be so big that it just copies and pastes all of that into your program and makes it really, really big. So you don't really want to do this unless you know what you're doing with it, but it's an option, and I'm going to show it to you right there. So again, only recommended for small, like really tiny functions. They get called very, very frequently, like millions of times. So if you're making a game, for example, maybe if you're calling something every frame that the game runs, you might want to inline some stuff. So if it's a small enough function like this. So again, that's just so that you're aware of that. Now, you might be wondering, or maybe you thought about this a little bit, why can't we make a template for this max function? And the answer is that we actually can, but we have a restriction on that. Instead of having 3 different max functions here, I could just have one. Okay, so I could do it, but the restriction is that our output variable has to be the same. It has to be the highest, or it has to be the most flexible variable type, because otherwise I won't know what we're dealing with. If I want to keep this code working, printing out this max value, because this is going to take a type name, and so you'll see in a second here. Let's change that back to t. I like t better, but you can do it with x. So we'll pass in a TA and a TB. So look at that. So we have a template that is inline for our max, and actually I could put it all on just one line, like that other one. So you can see the white space doesn't really matter too much. Okay, so we've got our max function and our print function, and now we're printing the max between the two. Okay. If I run it, it should work exactly the same. 2, 1.3, 1.3. So, yep. Okay, one last detail here. The important thing to remember with templates is that it might not always produce the intended result if you pass it a template that a type that doesn't work well with it. For example, I'll pass in an array here. So we'll do int array, just be an array of numbers, equals, what to say, 1, 2, 3, and 4. This especially gets complicated when you're dealing with custom types that maybe don't have operators like those implemented. So, and let's say we want to print the array that we just created. So instead of printing 1, 2, 3, and 4, it prints out this hexadecimal number. So that array is not exactly built for being printed out using cout. You'd have to define some sort of special case for that or something. There's also the weird situation of what if we do like, I don't know, like max array and array. Is that even going to work? What would happen? I don't know. Yeah, build error. So it can't quite, yeah, exactly. So an array is not a double, so it can only return a double, or can only return a type T, which I guess it could actually, I guess that could work. Well, there you go. So we can return a type T. Okay. So it still returns that hex value, but it's different from the one that was before. And I don't know if that's right or wrong or what. So again, make sure you're passing in the right thing. I guess I solved that issue just now. So you can actually, just so you're aware, you can actually pass out a template as well of whatever it was. But the key point is that it has to be the same thing that you passed in. So yeah, so we actually can simplify that max function. So I learned something new today. All right, cool. But it has to be the exact same type, unless, I wonder if this will work. Well, see, sometimes you just gotta experiment on your own. Like, what if we do 2 type names? Then you could get into some weird territory where I think you do, oh, what is it? Yeah, like int. Yeah, there we go. So these special characters here, the left and right triangle things, those are your variable definitions there. So the int matches up with the t and the int matches up with the x. Here I'm going to do float I wonder if I can do this actually. Can I do float and float like that? Or no, shoot, it's supposed to be up here. Although, you might wonder why you would do this if you went to the effort of making them templates in the first place, but hey, let's see. This gets to the point where you would need an int array. I don't know if that's going to work. Can you do that? Yeah, I don't think that's going to work. Can we do that? I'm not sure. If you know the answer to that one, feel free to let me know. But there's a lot of stuff you can do with these things. So if I run this again, I think that's going to work. So you can define multiple types that you are working with. Yeah, that works. So you can have multiple type names. So t corresponds to t, x corresponds to x. So you can input those parameters, t and t, and then return an x. Like I said, this is just all some optional stuff for you to mess with and learn about on your own. For most of my examples, I'll probably keep these to a minimum basically, but for more complicated things, you'll want to get used to learning about these things and know when to use them and know when not to use them. So that'll be it for today. So thank you for watching, and don't forget to like, subscribe, and look forward to seeing you in the next video. So thanks.